Here are 3 more examples of indefinite integrals. So again, what you might want to do is pause the video and try them, see how you do, and see if you can get the correct answers for these. So again, take a look, pause the video. All right, as usual, assuming that you've paused the video and given yourself a chance to try these indefinite integrals, remember that you're setting up, really, the chain rule in reverse. So, for the first one, if we look at this as the u being x to the 5th plus 3, we notice that we have an x to the 5th plus 3 raised to the 3rd power in the denominator. The proper derivative of that would be 5x to the 4th, and technically with the dx. So do we have the 5x to the 4th? Well, not quite. Let's go ahead and rewrite this so we can do a insertion of a proper constant. Remember that you can always adjust by a constant. So let's rewrite this as the integral. Now this is actually x to the 5th plus 3, all raised to the negative 3 power. And on the outside you have x to the 4th dx. So the derivative of x to the 5th plus 3 is 5x to the 4th. We can adjust by a constant. Now, students sometimes mistake this for being the natural log form. It would be the natural log form if it was simply over just that u by itself to the 1 power. But this is to the 3 power, so it's actually to the negative 3 power. So we can adjust by our constant and make it 5x to the 4th, compensating with 1/5 on the outside. And then doing the integral of this, I'll write it here. We've got 1/5 and then x to the 5th plus 3. The power goes up by 1, becomes negative 2. And then we divide by the new power, so that would be like multiplying by 1 over negative 2. And I'll include the plus c at the end. So 1/5, this is negative 1/10. X to the 5th plus 3 plus c. And always remember to include your proper plus c in order to be completely correct. And always remember that you can check your answers by taking the derivative, and if your derivative takes you back to where you started, you've done this correctly. So include the negative 2 right there. All right, the second one, x e to the negative x squared. So for this one, actually it's going to be the negative x squared that's going to be our proper u, negative x squared. Because the derivative of that is just going to be negative 2x dx. Do we have the x there? Yes, we do. So all we need to do is adjust by a constant. So let me get that ready to do that. Integral of e to the negative x squared, x dx. I'm not changing anything. I'm just writing it in another order so we can better visualize the proper u in the du. So we do have negative x squared, but all we have is x. But as usual, we're good to just adjust it by a constant. We need the negative 2 there, adjust by the reciprocal, which is negative 1/2, and we're set up to integrate this. And for this one, remember that The function e to the x is its own derivative and its own integral. So, for this one, we simply have negative 1/2 e to the negative x squared, and then include your possible constant plus c. Always remember the plus c in your final answer. All right, natural log of x over x. Sometimes the integral requires a little bit of insight to solve, a matter of really looking at it the right way. A lot of math problems are actually not very difficult if you just look at them in the correct way. What we really want to do is we want to look for something together with its derivative. Actually, do we see that right there? What is the derivative of the natural log of x? The derivative of the natural log of x is actually 1 over x dx. Do we have 1 over x right there? Yes, we do. Let me just rewrite it in a different way so we can see how we have the proper u and the proper du right there. Think of that as the natural log of x to the first power times its derivative, 1 over x dx. No adjustments are necessary. You simply have, right here, a function called u to the 1 power with its proper derivative here. So by doing the chain rule in reverse, you simply have something to the 1 power. So the integral of that, the power goes up by 1, and we divide by that power, and we have the natural log of x squared, then divide by the 2, 1/2, and include our proper plus a possible constant plus c at the end. So how did you do? Hopefully you're able to get all of these 3 correct on your own.